Tuesday, that we like to do a lot of connections. So for example, if the volume cooperates with doing the milling, if you've got a part that has milling and the volume is such that, then using a Takamatsu machine with live tools makes sense. For example, if you've got a lot of milling to it though, you want to separate out the turning and the milling. Always the difficulty with doing that is automating the machining center. And how to get the parts over to the machining center is always a struggle, right? So we have the MECTRON line. So the MECTRON line, what is MECTRON very quickly? MECTRON is a 30 and 40 taper Japanese machine tool maker. Back in the 80s, they supplied all the TSV series 30 taper drill taps to Miyano. Those guys separated many, many years ago, and we've been marketing now the MECTRON for the North America for quite some time. The thing that we like about, one of the things we like about the MECTRON is that they have their own built-in loader. So, and gantry rail. So it travels through the machine. So everybody else kind of would have a robot out here and you'd have some material handling and then you'd have the robot come in and load and unload. That. So that loader that you see is like a Takamatsu, right? They integrate the loader into the machining center. So what we've got here is we're doing the turning on the XW60, and then we have a standard shuttle device. Now we keep these in stock, these shuttle devices, a very, very simple shuttle device. Come on over here and I'll show you. So what we're doing over here, and if you can see this here, we're dropping the part off from the turning, and you'll see how that shuttle device is kind of just very simple cylinder that drives the part over, got a part present, tells us that we're there, and then we're loading it directly over to the MECTRON. So MECTRON has a variety of different 30 and 40 taper machining centers. You can see this one has a pallet changer. We kind of like this particular model because most of the time we find out that the turning is a lot shorter cycle time than the milling. So many times to try and have a balance, if you want to connect them like this and you want to balance out your cycle time, many times having a pallet changer on the machining center is very helpful in order to try and accomplish that. So let me just show you this real quick. Stay there, I'll be right back. I actually brought some papers with me this time. So just to give you, this is the kind of the MECTRON general catalog. Just to give you an example, MECTRON has a complete line of machining centers, not just this one. 30, 40 taper. We normally stock the 40 taper machines. I can give this catalog anyone. You can see they have many models that have the integrated loader. And we talked, you might have seen this one at the show. This is the 3-inch bar machine here. You can do 6 sides of the part, includes its own bar feeder. This is a very, very exciting machine. We're doing very, very, very well with this machine. And at the, I think I may have sent you guys some videos at the Gym Top, they actually introduced this model with 3,000 RPM turning. So not only can you do 5-phase machining, you can also do turning with this up to 3,000 RPM. So we're really about that. I just want to show you that really quickly. So this is the MTS C420. I brought this to kind of help me out here a little bit. 10,000 RPM. It's got a 12-station tool changer, 15 horsepower, the Nook controls. And let me tell you here what's included with this. So what we're going to do here in just a moment, I think he's showing you some of the process on it. And what we're going to do very quickly is, in a moment, we'll just stop the machine so I can kind of open it up and show you what's kind of included with the machine. But again, MECTRON is a very, very good builder. Japanese, they got a close relationship actually with Takamatsu. So the system between the two of them is really works very, very well. They help us a lot with that. So he's just going to turn this off. But you see how the gantry here moves over? So you can see here, we've got basically, so that you've got, and then we shuttle the part over and then load into this chuck here. You can put any fixtures that you want on the table, of course. If you want to have multiple fixtures, you can do that. And then we can just continue to load to the fixtures on this pallet, and then the pallet changes. And then we're machining over there while we're loading over here. And then it's got an extended gantry rail. The finished parts are coming out here, and then we just got them coming here out and out, dropping down into a bucket. Now, these MECTRONs, we sell these also as standalone. We sell these as standalone as well. If you say, well, listen, I don't want to connect it to a Pokemon, no problem. Sell this as a standalone machine. And over here, for example, we could put a stalker, tray changer, conveyor, so any type of material handling. I always bring these in as you see them with extended rail. So I can sell them as a connected machine. I can sell them as a standard. We have the stalkers, conveyors, to sell that as a standalone machine as well. And the nice thing is, you may want to use it for a standalone. At some point, the customer might say, hey, listen, I've got a job where I want to connect it to the turning. Very simple. It's multi-purpose. You can take this over and drop it into a turning machine for secondary work on doing all the milling work. So it's very, very flexible machine. And we're just excited. You can see the gantry moves very quickly, do a load, unload on the gantry. And the quality, we sold a number of these. The quality is really great. All Japanese made. MECTRON's been in business for, I don't know, 100 years or something. So they're a great company, great to work with. So let me, before we move on from this, I just went in, maybe we can stop the machine, and so bear with us just 1 second. It's just stop. I just want to show you the inside of the machine very briefly before we move on. So one thing that's included, so this machine, basically, it's about $180,000 for this machine roughly. And of course, includes everything that you're seeing, the gantry with the 3-jaw gripper hands. Also includes air seating. So we bring the machine in with air seating. We're stopped? Okay, good deal. So we can open up the side. Okay, so here's the inside of the machine. One of the nice things that they do is they've got a lot of different coolants. We've got bed flush coolant, got the kind of a shower coolant. So there's coolant kind of everywhere. The other thing it's included here is spindle through coolant device is included. We bring it in like that. We also bring it in, as I mentioned, with air seating, and hydraulics are plumbed through the joint here, as you can see. Well, this is air, but the hydraulics are also plumbed in here for hydraulic chucking as well. Tool chucks are not included in that price, but everything else is included. 40 taper, was it BBT 40? BBT 40. BBT 40 taper. So with that, let's move on to the XW. Oh, you want to go to this one? Okay. Okay, so I'll go over to the XW130 in a moment. John wants to do something here. Let me put this down. I'll be right back. John's the XTT 500. So let's switch our minds for a moment and let's talk a little bit about shaft loading. So Takamatsu has a few shaft loading machines. Now they also have, for example, even parts. If you say my shaft is like 6 inch long or something, we can even just go to an XT6 single spindle, single turret with a tailstock, really good price. And we can load short parts, auto load short parts to a tailstock. So wait a minute, longer parts, 15, 20 inches long. The XTT 500 can load up to about 20 inches part length into the machine. So you can see here the way this XTT 500 is designed, upper and lower turrets, so we can do kind of pinch turning and what have you. It also has a programmable steady rest. which is really nice because now you can engage the lower turret. A lot of other makers, as you know, in order to use a steady rest, they actually put the steady rest onto the lower turret, so it kind of disables your lower turret. But Takamats has a built-in programmable, so the movements are all programmable. You can program that movement anywhere you want. And so we can do all turning on here. So we could use a face driver in the spindle, and it has also included a built-in servo-driven tailstock. So the tailstock is actually programmable. You can see it over there. I don't want to put my hand in there. I think it's MT4, but it's the bearings are built into the whole tailstock. So it's a very, very rigid tailstock. And as you can, the tailstock actually works on its own slide. So it actually slides in. So it's a very, very rigid system. You might note the loader and unloader hands. They're kind of staggered like this. So back just a second. So you see that they're staggered in this fashion here. Why is that? Basically because on longer shafts, we want to basically avoid, so if we're doing the loading, we basically want to try to avoid the chuck. So that allows us to have a part in here and loading a part and give us more space here where we're not going to hit anything. So that's why they go to this type of staggered design, the load, for the load and the unload hands. Now, you'll also notice over here, I'm not gonna get too close to this. We got the guarding off, what have you, just to show you. But again, I like to bring them in with extended gantry rail, because the extended gantry rail allows us to be very, very flexible. I can connect it to another machine. I can put a lot of times we'll use what Takamats calls a V-block stalker, shaft stalker like this, that allows for parts to be put into like shaft longer parts, so kind of a V-block stalker, and then the gantry will pick it up right from the stalker. So typically this, we wouldn't use a kind of a station stalker, we would use kind of a V-block, or some people call it a walking beam type of stalker. So that's the type of design we would use for here. And then on the outfeed parts, we could put conveyor or another, that type of stalker, or gauging system or what have you, because, oh yeah, okay. My boss is telling me don't put my fingers in there, yeah. So anyway, very, very flexible machine. Boxway, again, 2 turret, tailstock, steady rest. Now we have one more machine, a larger one than the XTT 500. It's called the XS 700. 700 millimeters, so it's about 27 inches shaft length. So gun barrels or what have you, you can do with that. Big horsepower, can handle longer parts and heavier parts as well. So Takamats has now a number of gantry loaders that they can put on. We can get a smaller machine, and if you've got a really heavy part, Takamats can put on a bigger gantry. So they have quite a bit of different capabilities now relative to the different gantries that they can provide. So again, that's our shaft loading machines. Again, to review, right from an XT6, the smaller machines for like smaller shaft, up to maybe 6-inch part length. With tailstock, I keep the XT6T in stock. And then we go to our actual shaft loading machines, again, the XTT 500, and then we have the XS 700 for up to about 27 inches long part. So with that, let's move on to the XW 130. John tells me he's ready, so we're excited. So quick review on our XW series. So I mentioned the XW G3, which is the small machine, 8,000 RPM, even up to 10,000 RPM. Twin gang plate, that's that machine. And then we move up to the XW60, which is the 6-inch chuck twin spindle machine. Now we move up to the 8-inch chuck machine. So we have 2 models on the 8-inch chuck machine twin, the XW 130, and this one is the XW 130M milling. So this one includes 10 station turrets live at every station. A26 spindle, 15 horsepower, incorporates this. Now this machine we can go up to about 150 millimeter part size with this, so about 6-inch part diameter. If you need to go over 6-inch, then we go up to the XW200, which goes up to about 9 inches part diameter on the XW200. So let's talk about this one a little. So the XW130, again, box on box way. I'll show you that in just a moment. I typically bring them in with the stalkers. So we bring them in with the 16 station stalkers. Again, extended gantry rail, so that you can put the stalker on the left, you can put the stalker on the right, either way. Again, the nice thing about the stalkers is there's a screw here, just loosen the screw, it's on a cam, allows us to basically open and close the guides to accept different parts. Again, I'm finding some customers that don't want the labor to actually have to put the parts in a stalker or just the poles. Back to bin picking. That's a definite option if they don't like the labor involved in putting parts in a stalker. Never used, it's an issue now. Finding so many customers that really are looking to how to reduce every aspect of the automation, material handling, probing, different things in order to reduce the amount of labor content or input into the machine. So back to this. So you can see here, the turn device incorporates the same technology as the XW60. It's just the XW60 turn device is a little bit different, where it flips. You saw it flip like this. That as far as using the load hand and the unload hand, you can see there, it's doing that same theory, pick up, drop off, same time. So we incorporate that same theory, which gives us a very, very fast cycle time. Now you can see here how that's turning the part. No part in it right now, but that's how we flip the part. So that's all happening, of course, simultaneously while we're doing the cutting, operations. So again, we offer this XW30 with static turret or XW130M live tool turrets. And again, you can see, I didn't mention it before, but one thing I want you to notice is, with automation, chip management is absolutely everything. Chip control, because you don't have the opportunity for an operator to blow off chips. So we have to make sure that the process that we include is really bulletproof relative to any kind of chip problems. So some of the things Takamatsu does, you can see here that we have air. Can I put my hand in here? Okay. This is air, and this is kind of a flood coolant. So we have this right at the chuck area here. That's going to get rid of any kind of chips into this area here. And we can use air or coolant here. I also bring the machine standing with spindle through coolant, which is basically tubing that comes through the spindle. And then we use kind of an orifice or a stopper to basically disperse that coolant to get any chips out of here. I also have the M code switching to the high pressure coolant to the turret as well. We can also have or air at the turret in order to help get any kind of chips off of the tools in this area here. The other thing I want to bring your attention to also is look at this wide area here. There's nothing that's going to obstruct chips from coming down into the chip conveyor. Another great design by Takamatsu, having a nice wide open area so that the chips aren't going to build up in here. They go straight down into the chip conveyor, which then takes the chips out to the back of the machine. So with that, let's move around. Again, I talked to you again, extended loader gantry rail. Stalker on the left, stalker on the right. One thing that's good about that as well, if you get a customer that they buy 2 machines and they want mirror image, maybe they want to have all the raw material coming from here and the finished material coming here. They want to have one machine here. They want to have another machine here. So the extended rail allows you to have, for example, on this one, if I wanted the stalker on the right, this one I could put the stalker on the left and have all the blank work coming into here and here and dropping over here. So again, ergonomically and also labor aspect of it and material flow, these are aspects that we consider very carefully, and that's again with the extended gantry rail allows you to do that. Or we can put a gauge over here, we can put a conveyor, whatever you want to do. So the finished parts, We can drop the finished parts over here, or if you want, we can drop the finished parts back into the stocker, or we can add an outshoot and bring the finished parts to the outshoot here. Oh, one more thing. Come on over here. I forgot. So I don't know whether you can see this or not. John's not here with his flashlight. Here comes John with his flashlight. Again, I want to emphasize the construction of Takamats. The absolute rigidity of the machines is amazing. You can see that's a very wide saddle box on box way design that Takamats incorporates. Very, very rigid. Hand scraped, diamond lapped, no turkite, very, 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 very rigid. And let me show you this as well. Sorry, this is over here. Let me move this for a second. So let's talk about this. Watch your head. This is the so let's talk about this a moment. So you've got the two spindles, you've got the two turrets. You've got hydraulic lines feeding into the turrets. You've got a lot of heat generated into this general area of the two spindles and the two turrets. So thermal growth has never been an issue with Takamats, but one of the ways that Takamats use thermal growth is in the bed of the machine, just below where the spindles are, just in that bed of the machine, we circulate coolant. So this is the coolant tank and this is the radiator here. So think about this theory like your car engine block. How do we keep the engine block cool? They circulate coolant into the casting or base of the engine block. Same theory here. So we're able to hold a very constant temperature, which manages thermal growth like amazing. And the other good news about this is that, for example, if the operator goes to lunch or something, as long as the machine is powered on, we're going to continue to circulate that coolant in the bed. So when the operator comes back, he doesn't have to do a warm-up cycle in order to get size back. So we're able to hold the size perfectly using this system. So this is included on XW60, XW130, XW200, all the XW series. It's included. And we have some options on the new XT6 on the single spindles as well for that type of coolant system. So with that, what's the time, John? Oh, good. Okay, I'm way ahead of schedule. Okay, now, this is what I'm really, really excited about. I'm excited about a lot of things, but let me tell you this. But first, let me just explain one thing. So up till now, Takamats has had their own loader PLC, which is, this is the current style for Takamats. They have their own loader teach pendant and so on. It's really great. It's easy for operators to use and so on. But Takamats is now transitioning to something that's really, really exciting. So this is the fan of control. It's the new zero ITFO. First, let me tell you about the machine really quickly. So this is the new XT8MY machine. It is it's got Y-axis, standard BMT 55. I think it's 20 horsepower without checking. I think it's 20 horsepower HU6 with loader. Again, box on box way machine with loader. And so I can do it loader like this. And you can see this one has in and out feed conveyors. So I can use it with in and out feed conveyors. I can also put a stalker on here, different types of material handling. This one I got it with the in and out feed conveyor. So again, Y-axis. So this is single turret, live tool, Y-axis, boxway machine. But now for the really cool part. Takamats is transitioning to the new 0TIF Plus, but the loader is integrated into the FANUC. So, and I don't know if you guys know that this particular FANUC control, I don't know if the other ones are, this one's Windows based. So it's an open architecture. So in a little bit more detail, but let me just talk to you a little bit. You see this screen here. So this is the cutting program. This is the X, Y, and Z cutting program here. This is showing you the X, Z, C, and Y axis. You see the percentage of torque position. This is the loader. So you can see the loader information is right on the same screen. So what this allows you to do, is because it's an integrated FANUC loader, you can program the movements of the loader either here, or you can put them on a laptop and load them in. But the movements are just actual, you can actually program the movements. You don't have to think about point movement. You can actually program the movements as you would program the XYZ. So no more software changes. You have total access and control. It's very simple. We used to use different ways of, for example, opening and closing the gripper. It's all done by standard M code. You just put an M code into the program, open, close. Very, very simple, very, very user-friendly, very, very open. For example, and John will show you in a moment, if I say, okay, this one doesn't have an extended rail, but for example, if I wanted to take it over here and come down, I don't need any software change. I just program it. I just program that movement. Which one is this? Z, right? From the loader, Z and Y. So this is Z, so on the loader. So you would just program Z movement, Y movement. So everything is open. It's totally programmable. Not only that, but talking about says, yep. Hello.
Will this be a standard control for you in the future on all of your auto-loaded machines?
It is. This is the future. Takamatsu is going to this already. The machines I'm getting in the XT6s already have this loader on it. As you can see, the XT8MY has it. As they transition machines and we come up with the new models of machines, everything is going to be going to this FANUC. It is so fantastic. John's going to show you some other things about this, but I mean, the IT technology, the availability to program the loader, whatever you want to do is open. IO is there. I mean, it's completely, and anyway, to answer your question, yes, this is the direction where Takamatsu is going into, the integrated FANUC loader system into all their machines. As I say, a few of the machines already have it. This one does, the XT6, this is the XT, so the XT6, XT8 already have the integrated FANUC. And they're working on now on like XW60, XW130. Those are going to be revised coming into 2023, later on 2023 and what have you. I'll talk to you about that. But yes, this is the direction where Takamatsu is going. And it is absolutely fantastic. So I'm going to let John talk a little bit about and explain what we're showing here very quickly.
Hello?
Yes, me.
Okay.
Okay, so John's going to talk. Did you mute me? Go ahead, John.
Sir, good morning. Everything that you see in here, it's like a machine, another machine. Yeah. Sir, can you hear me?
Yeah, we can hear you.
Me? Yes, sir. Okay. Yes, sir. Whatever you see in here, it's like having another machine. It's like we can use a CAN cycle. You don't have to use the program. Example, when you're doing a tapping, example, before you do a rigid tapping, you have to go in front of the hole, and then you can just set it up as a position. This one, it does call out like a position 1, 2, 3, the same as the Sigma loader. However, you don't have to set up all the points in your loader. What it does is that because you're using a CAN cycle, you can do it faster, and it's an open-based system. This is the example that what you see in here is a Y5. It means we're going to position number 5. It's a G100. It's like a rapid movement. So everything, you can control everything with this machine. As Chris Bird has mentioned, everything about the loader, it's FANUC based. So the loader hand, the pusher, everything that you see in here, including the in conveyor. We don't have outwork device in here. Everything you can control. Even you're familiar with the Sigma loader, the area one, the area of the Sigma loader. That one also is through a data table. So you can change everything how you want it. Now, this particular machine, we can say, let's say, you want to change and then we can always, just like, you can treat it like another machine. So it's a conversation in a sense, because the moment you press a button, it's going to ask you, is that what you want? Just like in the computer, do you want to save this file or something like that? And then when it's not, it's just going to show you the start condition right here. If it's not starting, it's going to show you why it's not starting. It's going to tell you what it is. So I'm just going to stop the machine, and some of the things that I think what is cool about the loading system. I'm talking about particularly about the loading system. So let me just, when this stops, just give me a few minutes. Yeah. Okay. Everything, the speed you can control. If you want to speed it up more, then it would be okay. Okay, now some of the features, the new features of the loader. So let's say everything, as I mentioned, you have many points. Like if you look down, you have 59 points that you can use. Either you can program them, you can set them up, or what it's showing in here, the program itself, all you need to use are the one in blue, the 0, 2, 8, and 5. Example, you don't have to, if you look in here at the points, example, position number 3, it's not even populated. There's a reason for that. Because it's going to use a can cycle, you can actually indicate what points, example, Z8, you can say Z8, and then they say there's another variable, like it's the variable that we use is E. You can indicate the position with regards to the position number 8 so that you can go to position. So it will go to position number 3. However, if some programmers, they want to populate this, the whole 3, 9, 6, 7, 8, 7, 4, or 1, you can absolutely do so. All you have to do is go to the programming aspect of it, and use that as your own value. And some of the positions, let's say, I want to say point movement. There's a point movement in here. So let's say I just want to go to number 5, the simple one. Yeah, I want to go to number 5. So this is how I do it. So as you can see, number 5 is around here. Number 5 is picking up the part. But I can use the handle. Let's say I'm going to use the handle. Okay, Z-axis. So this is my my number 5, which is to pick up the part, a finished part. So what I'm gonna do here, let's say, so I'm going to go to number 5, going back here again, position move, and then it says y-axis, so y. This is my point number, and then z. So this is my pickup point. One thing about this, which is Chris said that it's really cool, is you have an axis adjustment. What it does usually, of course, if it's not a mechanical, usually when the vibration when you pick up the point or you pick up the part, it should be less than like picking up a torque like the required is, it should be less than 2%. So if you look in here, if I say okay, and then I press the unclamp, and it's telling me the alignment. Oh, okay, it's just axis adjustment is complete, and it's fine adjustment is not necessary. However, if it's more than 2%, it's gonna tell you what type of value. And you say, if I say okay, then do you want to change the value? And if you say, okay, I want to change the value, just say okay. So basically, in order for the loader, it's gonna tell you, okay, there's too much torque in there, so we're changing the positions of your point number 5. So that's what good about this loader. So I'm not gonna copy, and so there the coordinate input, it's so easy, and then point copy, it's the same thing. Now the program number, you have program number 8001 to 8032. So you can program it like programming your cutting programs. And so we call it an open system. So
You guys can hear me?
Back. Okay. Hey, before we wrap up, one more thing that I want to show you about this, and John's going to help me with this. So you can see it's open architecture, very easy to program, totally open system. It's very simple and it's very smart. But one other thing I wanted to show you, as far as programming this, you can actually just feed in some data, right, John? You can tell it to the part diameter. You can tell it the distance from here to here, and the length, right? We can put in this length in here. If you know those values, you can just input those values and it'll automatically figure out the whole loading program for you. It does it automatically. So they have really put a lot of thought into this. Not only that, John doesn't even, sometime we'll get into the IoT aspect of it. Connecting, we can connect this, we can daisy chain this to another machine and feed back these programs to another machine automatically. I mean, it's so amazing, but it's so easy and it's so smart. As John mentioned, it can do adjusting for the torque, even right here. Right. Thing for the sensor, for the pickup point. So it's very, very simple, very, very open. And again, you can just simply program it. So again, no more software changes. So we could not be more excited about this. I'll tell you what, Takamatsu is an up and comer. When I was in Japan, the things that they're doing in IoT technology and data collection and just all the different things that they're doing right now is really exciting. The owner of the company, he's what, 38 years old, Mr. Takamatsu, is 38 years old. I mean, he's got a degree in engineering. They are all over the technology. They're always coming up with new technology, improved technology, and they're really putting a lot of time and effort and money into it. We could not be more excited about the future for Takamatsu. So with that, I will let everyone go. I appreciate all your time. Real quick, any other questions? Anybody's got any questions? Or you can email me or talk to me. I know I said this is interactive. We didn't do too much of that, but again, you can call me anytime. I can answer anything. Or if there's something on here again that you see that you say, hey, I've got a customer that I could sell that machine to or whatever. Again, remember, I can set this up anytime. Just give me a call. I can walk out here and do a Zoom and show you the customer what he wants to see. very quickly while you're sitting in his office. So keep that in mind. And again, we're all about selling machines. So any projects that you get, and you know we've got specials going on right now to the end of December, no reasonable prices refused. So again, thank you all very, very much for joining and sticking with us through this. Appreciate all your time, and look forward to working with you guys in the future.
Thanks, Chris.
Thanks, guys. Okay.
Wow.